Hey, Ryan.
How you doing?
Good. One second. Let me turn my volume up. Been having problems again using my mouse and my cursor. My computer goes crazy. Uh, Seemed like that happened a few times when we had sessions.
Hmm.
Um,
Do you need that website thing again?
yeah, if you don't mind, I didn't save it.
Yeah. On that thing.
Okay. Let's see. Which one? Oh, this spring final review packet.
Yeah.
Okay. Do you remember how far we got? Seems like
22.
we got the what?
22.
Did we? Okay. I can remember doing 12. I don't remember doing 13. You sure we didn't just get through 13?
Oh, maybe you're right. We worked up through 22 in class, but
Oh, okay.
um,
How many are
through
there?
I think 70.
Oh my goodness.
Yeah, there's a lot on here.
When is your test?
Wednesday.
So we're scheduled to have one more session before your test?
Yeah, and what's your Tuesday looking like next week?
Fine. Would you like me to move your Wednesday appointment to Tuesday?
Yeah, that would be great.
Okay. Okay, so next week I have you scheduled on Monday and Tuesday.
All right, awesome.
Okay. Um, so where would you like to start here? You want to start at
Let's just start
13
it.
or you want to start at 22?
Let's go 13.
Okay. Position this a little bit better. Find the value of W, then X. Okay. How can I find the value of W?
For this one, won't you need to use tangent?
Okay, that's correct. What's the equation that I want to write?
1 minute, I'm gonna grab a pen and paper and just
And
write it
your
out.
and your calculator, it looks like you'll need.
Yeah, I have that with me.
Okay.
Just so I can have it in front of me, it's easier for me to do
Uh-huh.
that.
So whenever you're going to write an equation to solve this particular triangle, always start with the trig function of the angle.
Alright.
So which trig function are you going to use?
Um, it'd be opposite and adjacent, right?
Okay.
So that would be tangent.
Okay. So what's the equation I can write?
Um, alright, it would be the tangent of 42 equals 12 over W.
Okay. Let's solve that.
Alright, you do the tangent first, like the tan
Okay.
of 42.
Okay.
Okay, and then that equals 12 over, like when you get that answer, like the tangent of 42 is 0.90. So,
Well, let's do it. You got your calculator? Go ahead and find out what the tangent of 42 is.
0.9004, but 0.9.
Now what?
equals 12. Do you divide it by 12?
Okay, in order to solve this equation for W, multiply both sides by W. Now what?
And then you divide by 12.
No? Our goal here is to get rid of the coefficient on the W.
Divide by 0.9004?
Yes. Yes. In other words, if we divide by 12, that won't solve for W. But if we divide by this, the left side becomes W. W is equal to that. Okay? Now let's solve for X. What can I say about the big triangle?
If
you have this number, what is 12 divided by 0.9004?
13.327.
Okay. So now we don't want to consider this little triangle here because that's not a right triangle. But we can consider the large right triangle. So let's write equations for the large right triangle.
All right, so it would be opposite, so it wouldn't be over hypotenuse because we don't have that. So would it be, oh, yeah, okay, I'm sorry. It would be the tangent of 27 equals 12 over x.
Is it 12 over x?
Yeah.
No. What's the adjacent side to 27?
X.
No. It's w plus x. Remember, we have to consider this whole right triangle.
Okay.
It's not true that the tangent of 27 is equal to 12 over x. That's not a true statement. What is true is the tangent of 27 is equal to 12 over w plus x. This side is w plus x. So it's 12 over w, which is 13.327, plus x.
Okay.
And now let's make sure you can solve for x here. So tell me how I'm going to solve this.
Do the tan of 27 first, which comes to 0.509. And then you're going to subtract, would you subtract x?
No, this is a little tougher. Remember the first rule of solving algebraic equations, or the first thing you usually want to do is get rid of the denominator. How do I get rid of the denominator?
So subtract 13.327.
No, we're going to multiply both sides by the denominator, just like we did last time. When we solved this first problem for w, we multiplied, but we had the tangent of 42 is 12 over w. We multiplied both sides by that denominator in order to get rid of it. So to get rid of this denominator, we have to multiply the left side of the equation by 13.327 plus x, which is only allowable if I multiply the right side of the equation by 13.327 plus x. And notice what happens on the right side. That's why we multiplied by it. So it would go away. Now we have 12 left on the right. And what do we do? That
equals 6.763.
0.509 times 13.327 is what?
6.763x.
No. Now we have to distribute it to the x also. In other words, we have to multiply that number by this number, and we also have to multiply it by this number.
Right.
So 0.509 times x. So now let's finish solving this.
So then don't you want to get 6?
Now we don't have any, we don't have any denominators anymore to worry about. So we can start moving the x terms to the left, moving all the numbers to the right.
All right, so just get rid of 6.763 and move it to negative 6 point. Yeah.
You got it.
And then divide everything by 0.509.
There's your answer right there. Well, then you want to turn that into a number, but
Okay.
What'd you say?
Oh, I asked, you answered it. I asked if you could leave it like that or if you have to solve it.
Actually, I just remembered this is multiple choice. So let's see. W was 13.3. And X, let's see, if I do quick math here, I've got 5.237 divided by 0.509. The numerator is a little more than 10 times the denominator. X has got to be 10.2. If you bring this up on a calculator, that'll be 10.2.
Well, not on the calculator, it's not.
Did we make a mistake somewhere? Let's see. I don't think so. Here, let me do this on my calculator. 5.2 divided by 0.51 equals 10.2.
Where'd you get 5.2?
I just rounded it.
Okay.
In other words, it shouldn't matter. Having these last two digits is not going to change the order of magnitude at all. It might make it 10.21 instead of 10.194 like I got, but notice our choices are 10, 6, 23, and 16.9. So all I really needed was the ballpark.
Oh, okay. Yeah, because I got 16.9. So I was just wondering.
How'd you get, you got what? 16.9, which is one of the answers.
Yeah.
But that answer goes with a W of 10.8. We figured out W to be 13.32. Remember the tangent of 42 had 12 over W?
Yeah, I know. I'm trying to see what I did wrong on my calculator here. So
Maybe you used a W of 10.8 instead of 16.9. I mean, instead of 13.3.
I don't know. It won't. I don't have the new software on mine, so it won't let me scroll up. I did 12 divided by 5 or 0.509. Got 23.
No. It's not 12 divided by that. It's 12 minus 6.763 divided by that.
Okay.
Notice what I have circled here. The above circle, not that one. This one here. It's 12 minus, because starting back to here, in order to solve that equation, we have to subtract 6.76 from both sides.
Okay.
So it's 12 minus 6.763, and then that is what gets divided by 0.509.
Okay, that's where I made my mistake.
Okay. All right, let's go to 14. I spotlight is mounted on a wall 7.4 feet above a security desk. Well, above a security desk, so this is 7.4. Here's the desk, and here's a spotlight. It is used to light an entrance door 9.3 feet from the desk. There's a door. To the nearest degree, what is the angle of depression from the spotlight to the entrance door?
So you just use it as like a hypotenuse?
Actually, the angle they're looking for is not this one. Angle of depression is this. And that is the same because this dotted line is parallel with the 9.3 line. And we have two parallel lines with a transversal. That theta is the same as that theta. That angle, the angle of depression, the angle of depression always has to be measured from the horizontal. Okay, I started to label it this one, but that's not the angle they're referring to. They're referring to this one here. And that is the same as this, and this we can solve with a trig function.
I'm lost here.
Okay, here's the spotlight.
All right.
Here's the door it has to shine on.
Okay.
Here's the desk below the spotlight.
Right.
So it allows us to create a triangle that's 7.4 feet high, 9.3 feet length base, and what they're looking for is the angle of depression. That is that angle right there. In other words, if this spotlight were pointed like this, how much would you have to lower it so that it points at the door? In order to lower it, I have to lower it this amount, theta.
Okay.
Okay? So that after I lower it, it looks more like this. So their question is what is the angle of depression? Well, angle of depression means what is the angle made with the horizontal? Well, the angle made with the horizontal is this angle that I've showed right here. We'll call it theta.
Right.
Unknown angles are typically theta. Okay, so how do we solve for this theta given this triangle? Well, we know this horizontal dotted line is parallel to this horizontal solid line. And because they're parallel, this theta has to be the same as this theta. They're the same angle. So if I can solve for this theta here, I will answer their question.
Well, then wouldn't you know it'd be a 45-45 triangle?
No, it's not 45-45. We know this is 90 here, but we don't know what this angle is here. So all we know is the height. So all we know is the height of this triangle is 7.4 and the length is 9.3.
Right, but if all triangles have to add up to 180,
Okay.
and they have to be the same angle, wouldn't it have to be 45-45?
No. This theta up here is not inside the triangle. That's outside the triangle.
Okay.
It just happens to be the same angle as this lower left angle in the triangle. Because this line is parallel to this line.
Right.
That makes this angle equal this angle. Which is good because we know how to solve for that angle. How do we solve for that angle I just circled?
I'm not sure.
Start with a trig function.
Well, it would be tangent.
Okay, so tell me the equation I can write.
Tan of x.
No, of theta. We'll call it theta. We don't need to turn it into an x. Equals what?
Okay. Equals 7.4. over 9.3.
Which is what in your calculator?
7.4 over 9.3 comes to 0.79.
Okay. So we have the tangent of theta equals 0.79. How do we get theta? We need to solve this for theta.
Okay, how do you do that?
Take the inverse tangent. In other words, the inverse function means, let's go over that. Let's go down a moment here. This is very important, part of trig. If the sine of theta equals 1/2, excuse me, I meant to write 30 degrees in there. True statement, right?
Right.
We take the trig function of an angle to get a number. Well, this is true if and only if the inverse sine of 1/2 equals 30 degrees.
Okay, so you use the inverse tangent of the 7.9 and it'll give you theta?
Yes. In other words, this relationship between trig functions and inverse trig functions is a very important one. Notice that we have angle there, number there. And it's the opposite here. We take the inverse trig function of a number to get an angle.
Okay.
Okay, so this is true only if that's true. So I can say if the sine of theta equals x, then theta equals the inverse sine of x, or inverse tangent, or whatever trig function you're dealing with.
Okay, I see.
So if we go back to this step right here, and we're solving for theta, the other way you can look at this is I am going to take the inverse tangent of both sides. When I take the inverse tangent of the left side, these two cancel and I'm left with theta. Theta equals the inverse tangent of 0.79. What does your calculator give you when you put that?
38.509.
Okay, that sounds... and that's a degree, 38.509 or 38.5 degrees, because she said round it off to the nearest degree. Ooh,
Okay, so
yeah, they're tricky though. They're tricky. It's very important. Oh, they've set you up here. 38.509 rounds to 39.
right.
So 39 is the answer. Oh, it would never round to 37. Yeah, I don't know what I was thinking. Hold on, my computer, my mouse is going Looney Tunes again. Move it far enough away that it doesn't interfere my wireless transmission, which is the only thing I can figure out's going on. All right. Hold on a second. Dog just chasing squirrels, that's all. All right, let's see. So the key thing here is knowing what angle of depression is and what angle of elevation is. If you have a surveyor surveying a big building, and the surveyor is trying to figure out the height of that building, he figures out this angle right there. That is the angle of elevation.
Okay,
Notice that it's the angle. Notice that it's the angle made with the horizontal. This is not the angle of depression. The angle of depression is you have to make another horizontal, and this would be the angle of depression if you were standing on top of the building surveying down at something.
Okay.
Okay, so this is the angle of depression. And it happens to be the same as the angle of elevation. It's just a different term, really, to kind of mean the same thing. Because that horizontals are always going to be parallel to one another.
Okay, now if I ask you for the angle of elevation and it gives you the angle of depression, you just do the opposite of that?
That's what we kind of did, is we solved for the angle of elevation in that problem, even though it asked for the angle of depression. Notice that we were asked for the angle of depression, this one here, and we solved for the angle of elevation, which was the same thing. But we had the data to solve for the angle of elevation. But we knew it was the same thing based on parallel lines and transversals.
Okay. So essentially it's the same problem.
Yeah.
Okay.
Okay. Find the value of x in this problem.
This would be another, this would be...
Whenever you see an angle that's not 30, 45, or 60 degrees, you know it is a trig problem.
Right. So this would be either sine or cosine.
Well, you can't really use cosine. You don't know this side here.
Oh, I messed that up in my little note here. I put it on opposite. That was my mistake. I wrote that out wrong.
Okay, so what trig function can you write?
All right, so the sine of 29 degrees equals 19 over x.
Okay.
The sine of 29 comes to 0.48.
Okay, hold on. Let's back up one step. Let's solve this the proper way. Let's first of all multiply both sides by x. And now let's divide by the coefficient of x, which is sine of 29. So x equals 19 divided by the sine of 29. So in your calculator, do 19 divided by the sine of 29 degrees right paren, and you'll get x. In other words, there's no need to do it in two steps like you've been doing it. You don't want to have to write a number out because necessarily you're going to round that off, and you don't want to round it off yet.
All right, now I'm a little confused. I got the answer, which is 39.2a.
Okay.
I mean, answer is A. But why can't I do it the way I've been doing it, which
because it requires you to come up with a number and write it down on a piece of paper, right?
Right.
Okay, we don't want to do that. Let's just solve this equation. X is equal to 19 divided by the sine of 29 degrees. This can be done in one step in the calculator. And not only that, but you don't have to worry about the round-off error. You're still going to round off the answer when you get it, but you don't want to round off prior to the final answer.
Okay, I see what you're saying.
And this also does not require that you write anything on paper. In other words, you can do this in one step in your calculator, 19 divided by the sine of 29 degrees. It'll give you that 39.2. Okay? I mean, since you have to do this frequently, I mean, we've had multiple problems where you have to solve triangles using trig, so we might as well learn to do it the proper way.
All right.
In a calculator. All right. Find the area. Well, Okay, what's the area of this parallelogram?
Isn't it just base times height?
Okay, so what's the answer?
2.3 times 4.1, 9.43.
Okay, it's pretty straightforward. What's this doing on the test? It almost seems too easy. That problem right there.
If we
Compared
cover,
to every other problem we've encountered, that one is bizarrely easy. Okay, this is more like it. Okay, what do we have to find for this? The area of the, yeah, find the area of the figures. Okay. All right.
so for this one, wouldn't you want to split it in half? Like do
Sure.
13 times 9 to get the square,
Right.
and then
13 times 9 gives you the rectangle. Okay, so it's the area of the rectangle. And what's the area of the triangle?
the area of a triangle is base times height divided by 2.
Okay, so it's 1/2 base times height. What's the base?
The base would be 11.
Okay, what's the height?
The height, that's 13. It'd be 5.
So the answer then is 13 times 9, which is 117, plus half of 55, which is 27.5. That adds to 144.5 square centimeters.
Okay.
That's pretty straightforward also. The area of a parallelogram is 320 and the height is 40. Find the base.
Wouldn't you just do, oh no, that would get you the area.
Always start off with the general formula. Then you won't have any problems. If
Well,
the first thing you write, the first thing you want, if the teacher says, show your work, the first thing you want to write is the general formula. What's the general formula for the area of a parallelogram?
Base times height.
What information have they given you?
The height and the area.
So, what are you going to fill in for height and area?
For the height, you could fill in 40. And the area is 320.
Now solve for B.
Why would you put it in parentheses? Because wouldn't that make it 40B?
It is 40B. It's base times height.
Okay.
It doesn't matter whether I put it 40B or B40. It's the associative property. The goal is to solve for the base. In other words, the general formula has 3 variables in it. Area, base, and height.
I don't know why. I guess when you wrote B, it just mixed me up, and then I looked at it wrong. But it comes to 8.
Okay. Find the value of H in the parallelogram. Okay. This is an interesting problem. This is different. How are we going to do this?
I'm not sure.
consider the parallelogram's first base not as 27 but as 36. In other words, a parallelogram can have either this is the base, 27, or if you flip it over on its side, 36 would be the base, right?
Right.
Okay, so flip it over on its side and start thinking about it. What's the area of that parallelogram?
Base times that height, 36 times 24.
Okay, what's that number?
864.
So that's the area of the parallelogram that we know it to be. Now let's consider the area of the parallelogram with it standing up like it is. Well, we know the area still has to be base times height. And we know the area didn't change. So I can substitute 864 for area. I'm solving for h. Well, I know the base is what?
The base is 27.
What's h equal to?
I'm not sure.
Solve this equation. 864 equals 27h.
Oh, divide 864 divided by 27. 32, so A.
This is a very clever problem. I'm not sure I've ever seen this type problem before, where you can solve this parallel. They don't give you h, so it's difficult to solve for the area when we view it as a upright parallelogram. But if we view it with our head cocked to the left a little bit, we see that this base, we have a base and we have a height. So I'm able to figure out the area of this thing. And once I know the area, and then I go back and view it as an upright parallelogram again, now I can solve for h. Clever problem. Very clever problem. I like that. All right. A fly lands at random on a point on the grid. Find the probability of the fly landing on the figure. So conceptually, what are we going to do here? How are we going to find the probability of the fly landing on this gray area?
Can you click on the problem real quick so I can see the answers? Just to see if they're all...
Oh, I had the denominators covered up. Sorry. Here, let me...
Yeah.
Okay. Probabilities are always ratios, right?
Right.
In this case, what is it going to be the ratio of?
Probably it would be, and it's 70, so you can cancel out
Hold on.
D.
Well, let's not solve it that way. It's important you understand conceptually how we're going to do this. We're going to take the area of the triangle and divide it by the area of the grid that the fly has an equal likelihood of landing on any of these squares. So the probability of him landing on this particular part of the grid would be the area of this triangle divided by the area of the grid. Well, what's the area of the triangle? It's got a base of 1, 2, 3, 4, 5, 6, and a height of 3. So the area of the triangle is what?
The area of the triangle is 1/2 base times height.
So that's what? Its base is 6, its height is 3.
Right, it would come to 9.
Okay, so that's the area of the triangle, and we're going to divide it by the area of the grid. which is 1, 2, 3,
70.
4, 5, 6, 7 times 10, I'm guessing, or is it 9?
Yeah.
1, 2,
It's
3,
10.
4, 5, 6, 7, 8, 9, 10. So there's your answer.
What I was doing, like I understood what you were saying. What I was doing, I was counting up to figure out what the denominator was. Just by
Okay.
saving time, you can do process of elimination.
Okay. Oh, I see. Okay. So you knew the denominator had to be 70. The only
Right.
problem with that technique is what if my numerator ended up being 18? Now that thing is going to reduce to this. So
Well, technically, wouldn't that?
my answer would not have 70 in the denominator just because the area of the grid is 70. It could end
Could she
up being
really?
a fraction that's going to get reduced.
Could the teacher really mark you off for that though, even though 18 of 70 is an answer?
No,
And
18 is not the answer. 9 is the
right, I know.
numerator.
Like if it was though, is what I'm saying. If 18 turned to be the answer, 18 out of 70, and you made it C.
Is all I'm saying is that you can't look at this problem and eliminate A as a possible answer. Because 9/35 is the same as 18/70. So if the area of this triangle was 18, 9/35 would be our answer.
Okay.
Okay? I see what you're doing, and I admire the attempted shortcut, but you got to be a little careful when it's possible that it could be reduced. All right, the area of a trapezoid.
That's base 1 plus base 2 divided by 2.
Right?
Right.
Because that gives you the average base times what?
Oh, times the height.
Okay, so there's the area, there's the general formula. Now, they haven't made it particularly easy on us. Here, let me draw this and see if you can figure out how to dimension it. Because that's the secret. They're not giving us a straightforward problem. They're giving us a multi-step problem. This is 7. This is 4. And I have not drawn this to scale. So we know the height and we know base 1, but we don't know base 2. So let's try to put some extra dimensions. What's the dimension from there to there if this is a 45-degree angle?
It'd be 45. Or from where to where?
From my hash mark to my hash mark?
It'd be a 90-degree.
Now, what's the dimension? What's the size of the distance? In other words, in order to get this whole base across the bottom,
It'd be 3 again, wouldn't it?
no. They didn't tell us this was an isosceles trapezoid. However, they do tell us this is a 45-degree angle. That makes this triangle over here isosceles because that and that have to add to 90. So if this is an isosceles triangle and this side is 7, what is this side here?
I'm not following you here.
Okay, in order to get the bottom base, we know that this dimension is 4 because that's a rectangle.
Right.
So if we can figure out this final dimension, we'll have the bottom base.
Okay.
So use a trig function if you have to. You need to solve for x. Forget.
Oh, so it'd be the tangent of 45 equals 7 over x.
Okay, so x
Divided
becomes,
by, yeah. So
What's the
7
tangent of
divided
45? Yeah, look up 7 divided by tan of 45.
so it comes to 7.
Aha! The property of isosceles triangles is if you have two angles that are the same, the sides opposite them are also the same. So we didn't really need to rely on trig here. If we just remembered our geometry, we'd have known that if this is 7, this has to be 7.
All right.
Okay, so now we have everything we need. So area is what?
Base 1 plus base 2 divided by 2 times the height.
Okay, so give me all those numbers.
All right, so base 1, 14 plus 4 divided by 2 times 7.
Correct. So that's 9 times 7, or 63.
What's that?
63?
Right.
Okay. Ooh. My computer is seriously... There are some information is not quite going right. Okay, this is a frequent problem where we have an equilateral triangle and we're trying to find the area of it. And as all we have is a side length of 12.
All right, so you would split it down the middle, right?
Okay, I'll drop a vertical, which we know bisects the bottom because it is an equilateral triangle. So this becomes 6 and this becomes 6. What now? Because we need this, we need the height.
Right. So then that becomes a right angle.
Okay.
And I'm a little lost from here.
I'm looking at the left part of this triangle.
Right. Okay. I
What's
got
that
it.
angle right there, theta?
The square root of 12 squared minus 6 squared. And that comes to 10.39.
Okay, so h is 10.39. So what's the area?
The area? Oh, base times height. So, roughly 60. Well, I guess I should times that by 6 and divide it by 2. 31.17.
Okay, we want the area of this triangle here, not this one.
Oh, okay. So then it's 12 times 10.39. Divide that by 2. It's 62.34.
Which answer is that equal to?
Wouldn't it be A?
Yeah, it certainly isn't C or D.
Right.
It could be B if we're off by a lot, but we shouldn't be. But the best thing to do is put that into your calculator. Multiply square root of 3 times 36 and make sure you get 62.34. Or at least in the neighborhood.
Okay. Yeah.
All right. Area of a rhombus.
I do not remember that formula.
About the area of a kite.
I know it has to do with like diagonal 1 plus diagonal 2. times diagonal 2, but I don't remember it.
And there's D1. There's D2. So what's your guess? If it's a function of the diagonals,
D1 times D2 divided by 2 times the height?
yes. No, just D1 times D2. But clearly that would give you a bigger area than we want, because that would give you the area of this rectangle. Right?
You divide it by 2, right?
Exactly. So there's the formula for the area of a kite. Well, a rhombus is just a special kind of kite. So if we can figure out these diagonals, then we can use the formula for the area of a kite, because it has to apply to a rhombus. The only thing extra special about a rhombus is all four sides are the same, which means the diagonals bisect each other, whereas with a kite, they do not. Okay, but the only reason I made a kite is because if you can remember the formula for the area of a kite, then you can use it for the rhombus. So let's look at this rhombus for a second. Rhombus is basically a diamond, like a baseball diamond. This dimension is 5. This angle is 60 degrees. That should be all we need. What is this dimension over here?
60 degrees.
That's an angle. What's the dimension of this side right here?
5 then.
Okay. Now let's solve for x, because if we can solve for x, which goes from here to here, then we'll have the second diagonal. It'll be twice that. So let's solve for x.
Wouldn't you have to do a 30, 60, 90 triangle?
Or use a trig function. Either one.
Oh, it'd be cosine. Oh, no. Because you don't use the hypotenuse.
You have to find, here's the trick. Look at the angle.
Right.
And look at the available information. Well, x and 5 is all we have.
Right. I got confused on
Okay.
x always being on bottom, so I was thinking opposite had to come first.
Well, this actually makes it easier to solve, the fact that x will be on top. So what's the equation I can write?
The tangent of 60 equals x over 5.
Multiply both sides by 5. What's x equal to?
What do you mean what? Oh.
Go ahead and put this in your calculator.
Tangent of 60. Tan of 60. That comes to 1.73 times 5. 8.66 equals x.
Okay, so what's the second diagonal?
8.66.
No, that's just half of the diagonal. Remember, I was just solving that triangle right there.
Right, so don't...
But the diagonal runs from top vertex to bottom vertex.
Oh, I thought you just meant that solved the line that you drew the dashes on.
No, I solved for half of the diagonal. So what's the entire diagonal?
The entire diagonal would be 17.32.
Okay. So now the area of this thing is diagonal 1 times diagonal 2 divided by 2. So help me plug in the numbers. What's diagonal 1?
10.
What's diagonal 2?
Diagonal of 2.
No, what's diagonal 2? The second diagonal.
Right. It would come to 17.32.
All divided by 2. So the answer is 5 times 17.32, which sounds like about 85. So which of those answers, wow. Which of those answers looks like 85?
The closest it would be 50, wouldn't it?
Yeah, notice that, boy, notice that, I can't write anything, wow. Huh. Ah, okay. Notice that 50 times square root of 3 is equal to 50 times 1.7. And what we were doing was 5 times 17.3. So our answer, which was this, is the same thing as 50 times 1.73. So it's D. It would have been probably a little easier had we not used trig, had we used similar triangles, because then we would have measured x as square root of 3.
Huh.
Or it
Okay.
would have been 5 square roots of 3. Right?
All
In
right.
other words, the disadvantage of using trig functions is you don't get your answers in radical form. Here, let's go back and cover this because this is important. You should be able to do it both ways. I'm trying to solve for x. Don't do it the trig way. Let's do it using similar triangles. So here's my similar triangle, my unit. I don't care what it would be. I could use a double unit as long as it has dimensions on it, because this triangle's got to be a multiple of this triangle.
Right.
So what are my dimensions on the smaller one?
On the smaller one,
Yeah, what's opposite the 30?
opposite of 30, isn't that root 2?
It's always 1. In other words, the reason I call it my unit special triangle is because the smallest angle in both the 30, 60 and the 45, 45, the side opposite the smallest angle is always 1.
Okay.
What's opposite the 60-degree angle?
That would that one be 2 then?
No, that's the root 3. Here, the way to memorize this is the hypotenuse has to be the biggest number. So if you know there's a 1, a root 3, and a 2, well, root 3 is 1.7.
Okay.
So the 2 has to be the hypotenuse.
Is that the same for 45, 45, 90
No,
triangles?
no. Its dimensions are going to be 1, 1, square root of 2. Okay, so now let's solve this problem using similar triangles. What is x?
X would be 1.
No. The way we do this, let's go through this one more time.
Oh, I'm sorry.
We need a scale factor. What's our scale factor going to be?
Right, I didn't orientate it right the way I was looking at it. So X would be X over root 3.
What's the scale factor? Let's start where we're supposed to start.
Scale factor would be 1 or 5 to 1.
5 to 1. Always take the big one divided by the small one. And you're finding the side that's the equivalent, opposite the 30-degree angle, with this side that's opposite this 30-degree angle. So we divide 5 by 1. That's the scale factor. Now what? What's x going to be?
X is going to be 5 root 3.
Right, because we take that scale factor, multiply it by the side that's opposite the 60-degree angle, and that gives us 5 root 3. Notice that if we'd have solved this thing doing that, we would have ended up getting our answer 50 root 3 instead of 85 point something.
Right.
So we would not had a conversion that we would have had to, that we were forced to do. We wouldn't have needed to do that. In other words, by looking at the answers, she's kind of suggesting that you solve this using similar triangles, since this is a 30-60. Personally, I think whenever you see a 30-60 or a 45-45 right triangle, you should always use similar triangles and not use the trig function. You can do it either way. You can either do it using Pythagorean theorem, which also gives you your answer in terms of radicals. But we couldn't really do this using the Pythagorean theorem because we knew this was 5, but that's the only dimension we had. We didn't know what this was, and we don't know what that is. So the only thing I really have to use here is similar triangles or trig. And similar triangles really works better when you're looking at a 30-60 or a 45-45.
Okay.
Okay? All right, so we got through 23. So let's tackle this puppy next Monday.
All right, that sounds good. And then I got you again on Tuesday, and then you canceled the Wednesday.
Yeah.
Okay, and then, so here's the deal right now. Since this semester has been harder, the tests haven't been going as great, so I'm in jeopardy of not passing.
Okay.
So it just depends on what the final comes to. I might have to do an online course over the summer.
Okay.
So do you work over the summer, or do you take
I
off
do.
as well?
No, I'm available most of the time. I don't. I'll play more golf during the summer, so I might have days blocked out where I have a golf game. But if you go on my website, you can always see my availability, and it'll always allow you to schedule it online if you like.
All right.
Okay, so all you need to do is just go to my website and check my availability and pick what you want.
Okay,
I
will do that.
got lots of time available in the summer. So.
Alrighty, sounds good.
Okay, all right, but let's get you past this course. You should be able to pass this course.
That's what my hope is. So.
All right. Okay, Ryan, I'll talk to you Monday.
Alrighty, thank you.
Bye-bye.